The face detection process runs directly on the camera. It detects human motion, extracts a person's face from the scene, and sends the cropped face snapshot together with the video stream to the NVR. This allows users to later search and review all faces detected by cameras with the face detection feature enabled and connected to the NVR. The feature is not intended for identifying or searching for a specific individual. Instead, it presents a list of faces captured over a predefined time period, often from multiple angles and across multiple cameras. The face recognition process is based on receiving face data from the camera as a result of face detection, analyzing the facial features, and generating a unique digital signature for each detected face. The digital analysis of the face snapshot is typically performed on the NVR itself. This face recognition process can run on multiple channels simultaneously, depending on the NVR model. On higher-end models, up to 16 channels of face recognition can operate in real time, meaning that every detected face from up to 16 channels is analyzed, digitized, and made available for the later search. The NVR can store up to 10,000 faces in its local storage on the NVR hard drive, each with a digital signature, making it possible to search for random individuals by using a reference face snapshot of the person you are looking for. Let's assume an NVR with 4 connected cameras. The first 3 channels are configured with face recognition on the NVR, while the 4th channel is configured for face detection only. This means that when a person is detected, only the first 3 channels generate a digital face signature that can be used for searching later. As a result, face recognition searches are possible only on those 3 channels. If we perform a face detection search across all 4 channels, we will see all detected faces from every camera, including the target. However, if we search for a specific individual using face recognition, as illustrated on the table on the right, the results will include only the first 3 channels. This is because only those channels generated a digital signature for that face, enabling identification and targeted searching. Another important capability of face recognition is the ability to store specific faces on the NVR and use them to trigger customized reactions. The NVR includes a dedicated face database storage area on its hard drive, separate from regular video storage. Within this repository, it is possible to create up to 10 different face databases, groups, and store up to 10,000 faces in total. This allows us to organize faces into groups and define different responses when a face from a specific group is detected by any camera. The process works as follows. Cameras capture face snapshots using the face detection mechanism and send them to the NVR. In real time, the NVR analyzes these snapshots on all channels where face recognition is enabled and compares each detected face to the faces stored in the NVR's face databases by matching their digital signatures. When a match is found, the NVR can trigger a predefined reaction. Faces can be organized into groups, and each group can have its own response logic. For example, detecting a face from a VIP group can trigger a sound notification and an alarm output to open a door, while detecting a face from a blacklist group can trigger a different alarm output or activate a siren on the NVR or a connected camera. An additional advantage of Provision ISR face recognition is the ability to add faces to the NVR directly from the Cam2 application. Using either the smartphone's camera or the photo gallery, a face can be captured and uploaded to a selected face database, allowing fast and convenient face management from a mobile device. Let's start by explaining the face detection process. First, we will configure the NVR to display detected faces in the right-hand panel once the cameras are properly set up to send face snapshots to the NVR. When we open the face recognition screen on the NVR, we can see that 6 cameras are connected, each supporting face detection analytics. Enabling face detection on a camera channel does not affect the face recognition capacity of the NVR. However, once face recognition is enabled on a channel, the NVR's face recognition capacity is reduced accordingly. In this model, each active face recognition channel consumes approximately 16% of the NVR's total face recognition resources. This means the NVR can process face recognition simultaneously on up to 6 cameras, with each enabled channel allocating a portion of the available processing capacity. Let's go through each of the 6 cameras and make sure that face detection analytics is enabled on all of their channels. Since the NVR hard drive has been formatted, there is currently no stored face data. As a result, no face detection results appear when searching in the analytics section of the NVR. Now let's test the face detection process. We'll present the same face to all 6 cameras, and once that's done, we'll open the Analytics search menu on the NVR to review the results. From the results, we can see that all cameras successfully detected the faces. However, when we select one of the events and try to search for that specific face, no results are returned. This is because face recognition is not enabled on any of the channels. Only face detection is active. Similar to the analytics search on the NVR, the same process can be performed in the Cam2 application when searching for faces. Simply open Event Search, select Face, choose the relevant date, and then pick one of the events from the results to jump directly to the playback of that event. Now let's enable face recognition only on camera AD3. As explained earlier, activating face recognition on a single channel will consume 1/6 of the NVR's face recognition resources. Also, make sure to set the schedule to 24/7 since the default setting is never. After we show the face again to all cameras, we can return to the Analytics face search on the NVR, this time to test a specific face search. Even if we take a face snapshot from a channel where face recognition is not enabled and use it as the search target, the results will appear only on camera AD3, where face recognition is active. This demonstrates that when a snapshot is selected as the search target, the NVR digitizes that image and compares it against all stored face recognition signatures from the channels with face recognition enabled. Let's enable face recognition on an additional channel, bringing the total usage to 1/3 of the NVR's face recognition capacity. Make sure the schedule is set to 24/7 so the system can capture and recognize faces immediately. In this experiment, we'll present the face partially covered, for example, by placing a hand over part of the face. To further emphasize a point, we'll take a face snapshot from a channel without face recognition enabled and use it as the search target. As you can see in the results, matches are now returned from both channels where face recognition is active. This demonstrates that even when part of the face is obscured, recognition can still succeed because the eye region, which is the most critical area for matching, remains visible. Let's enable face recognition on all 6 channels of the NVR, bringing the system to 100% face recognition capacity. By clicking the AI Resource button, we can see all the channels that are currently consuming the NVR's face recognition resources. For the next experiment, we'll present the faces of 2 different people to all 6 cameras. Once that's done, we'll open the Analytics search section. The recognized and unrecognized classifications apply when the NVR database already contains enrolled faces versus people who are not in the database. However, for this test, that distinction is not relevant to our search. Before we start searching for a specific face, let's return to the face detection events and note that the NVR interface allows 2 viewing modes. We can view events as scene thumbnails, showing the full frame of each event, or switch to a list view by clicking the Details button. We can use the filter option to select specific cameras and limit the results to those channels only. In addition, by enabling Identify Registerable Snapshots, the system will highlight in green only the high-quality face snapshots that are suitable for being added to the NVR database later for face recognition of specific individuals. To preview an event related to a specific face, simply click on the snapshot and the corresponding event will be displayed in the left corner of the screen. Once we perform a search using one of the snapshots, we receive results for that face across all 6 channels, exactly as expected based on the configuration we set up earlier. Clear and replace the search target face. Click the plus icon and select the face from the recent searches to look for a different person. You can also adjust a similarity level to make the search more or less strict, which will generate a different set of results. Let's move on to managing the faces database on the NVR. One way to register a face is to open one of the recent events captured by the cameras from the right-hand panel, and then open that event in a separate window. From there, we can register the detected face into a specific database group. Another way to do this is through the analytic search. Find one of the face snapshots and make sure it is marked in green as explained earlier, indicating that the snapshot quality is sufficient to be registered in the database. Face registration can also be done from here. Let's assign a name to this face and set the appropriate group for it. The Faces database groups of the NVR can be accessed from this screen. Under the VIP group, we can already see the face that was added earlier. Next, create another group called Block, which will serve as a block list. From this interface, click the Add button and search for faces in the library, where you can see various face snapshots captured by different cameras. Select one of the faces with a green mark, assign it a name, and add it to the Block group. At this point, we have one face in each group, and we can move on to the next step, configuring how the NVR should respond when it recognizes a face from one of these groups. Let's open the face recognition screen and configure a reaction for successful recognition of faces from the VIP group. Set the schedule to 24/7 and note that this reaction is defined per group and per camera, in this case for camera AD1 only. The configured reactions for recognizing a face from the VIP group will include a full-screen pop-up of camera AD1, a push notification sent to the Cam2 app to alert about the detection, recording on multiple channels, and triggering PTZ presets on selected PTZ cameras. However, since a full-screen pop-up would prevent us from seeing the PTZ cameras moving to their presets, we'll disable the full-screen pop-up and use a buzzer alert instead. We can see that when a person from the block list is captured by any camera that sends face snapshots to the NVR, the face is analyzed and recognized. As a result, the person's name appears in the right-hand panel, but no action is triggered, since no reaction has been configured for this group. In contrast, when a face from the VIP group is analyzed by the NVR and the detection comes specifically from camera AD1, the configured reaction is activated. Multiple PTZ cameras move to their predefined presets, and the NVR buzzer is triggered. Now, return to the face recognition screen and click the plus button to create a reaction for the blocked group of listed individuals. This will open a new tab where you can define a specific reaction for this group and set the schedule for when face recognition on this channel should be active. For this group, configure the reaction to display 911 in the right-hand panel and to trigger alarm outputs, which will activate external devices such as small sirens. In summary, we now have two separate tabs, each defining a different reaction for a different group. These reactions are group-specific, and in this case, apply only to the AD1 channel. When we test the setup, we can see that when Ari presents his face to the AD1 camera, the configured reaction is triggered, and the external devices are activated. Now let's look at the scenario where we want to react to a person who is not part of any Faces database group. In the face recognition screen for camera AD1, we can configure a reaction for unrecognized faces by using the appropriate tab. Here, we can define the schedule, set a text prompt if needed, and choose the specific reactions for this type of event. For example, a video pop-up, a message box pop-up, alarm outputs to trigger external devices, as well as PTZ camera actions with multiple preset movements. Now let's test this configuration and see how it works. Once the NVR detects on camera 81 a face belonging to a person who is not registered in any of the Faces databases, it will trigger an on-screen message along with a full-screen pop-up of that channel. The face tracking function on the NVR allows the user to upload a background image of an environment, such as an office or a factory, and place the installed cameras within that scene. This makes it possible to visualize a specific person's movement through the space, based on detections from each of the face recognition channels. To demonstrate how this feature works, let's assume we have 6 PTZ cameras installed in our training room, with each camera configured for face detection and face recognition running on the NVR. Now, a person will move between each of the cameras, presenting their face to each one individually to ensure that a sequence of appearances across the cameras is created. On the right-hand panel, we can see the history of detections, showing how the face was captured by each camera and confirming that the face was successfully recognized each time. The creation of a tracking map is done in the Analytics section of the NVR. After searching for faces, we select a specific face to use as the target, the person we want to track. Once selected, the system gathers all events in which this person appears. Next, click the Track button. Here, we can configure the camera label appearance, the camera icon text, and, most importantly, upload a background image. In this example, we use a USB stick to import a JPEG file that represents the environment. Once applied, we position the PTZ cameras on the background to match their real-world locations in the room. Now, when we play back this person's events, the camera that captured each event will change color to red, clearly indicating where the detection occurred. We can switch the layout so the main view becomes a preview, allowing us to follow each event on the map while stepping through playback. Finally, we switch back to the original view and click Track Play. This generates a motion path showing the target's movement between different points, clearly visualizing the sequence created as the person moved through the room. We can use a Cam2 application to search for a specific person in several ways. The first method is to search by name, provided the person is already registered in one of the Faces database groups. Once the correct person is selected, we can define the date range and time period, then start the search. This will return all events in which that person appeared in front of any camera that has face recognition enabled. Clicking the icon in the upper right corner changes the event display to show small face snapshots of the person as they appeared in front of different cameras, giving a clearer view of where the person had higher activity within a specific area. Clicking the same icon again switches back to the event view, where we can review all of this person's activity over the selected time period by using Fast Playback and the Next button to step through the events one by one. We can search for a random person using the Cam2 application by capturing their face with a smartphone camera, which requires the person to be nearby so their face can be clearly captured. The image is then sent to the NVR, digitized, and used as a search target, exactly the same way face searches are performed directly from the NVR interface. If the person is not currently near the smartphone, the search can still be performed using a photo from the phone's gallery. By selecting an existing image of the person, the system will return all matching results for that face, exactly as in the previous example. Up to now, we've used the analytics window to search for a face and display the results as snapshots or scenes. However, there is another method that allows us to track a specific person's activity over time. This option presents the results on a timeline, showing clear markers of when and on which channel the person's face was captured and recognized. Once we open the playback of a selected channel, we can see different colors on the timeline representing various recording events, including motion, analytics, and time-based recording. When we switch to Smart Playback, the timeline colors change. Motion events are displayed in blue, while all other types of recorded events appear in white. From this screen, clicking the face icon allows us to select a specific face, either from recent searches, the gallery, or the face database, and start to search by choosing Select by Face. Initially, no results may be visible due to the timeline marker being positioned incorrectly. However, once we disable the common filter and leave only the face recognition events related to the selected person, a small number of relevant events will appear on the timeline. By clicking on any of these events, we can clearly confirm that the person shown is the one we were searching for. This approach makes it much easier to understand on a specific day's timeline when and on which channel the person was captured. As we select and zoom into individual events, it becomes clear that each event indeed includes the person we were looking for. Faces can be added to the NVR database not only from the local NVR interface, but also through the Cam2 application. Using the app, a face can be captured with the camera or selected from the gallery and then assigned to a predefined group on the NVR, along with its associated reactions. As you can see, the NVR currently has two face groups: the logistics group with 3 registered faces and the sales group, which is currently empty. Let's see how we can add a new face to the sales group using the Cam2 application. Let's add a new face using the Cam2 application. First, make sure to select the correct NVR from the NVR list. Then, click the 3 dots and choose Add New Person. Since the person is not nearby, we'll select the face from the smartphones gallery. Finally, assign a name and choose the appropriate face group on the NVR. Once we finish uploading the image to a specific group on the NVR using the Cam2 application, we can return to the NVR and verify that the database has been updated correctly. In the Faces database, the Logistics Department group still contains 3 registered faces, while the Sales Department group now shows a newly added face, confirming that the changes made in the Cam2 application were successfully applied. The face recognition logs accumulated by the NVR based on the activity of multiple people in a specific area can be used to create a face attendance report. This allows us to identify anomalies such as individuals arriving late or leaving early, and to narrow the search in order to generate reports for a very specific time range. Let's check our NVR. When we review the available databases on the NVR, we can see that it contains multiple face databases, one of which is employees, holding 4 different registered faces. Next, we open the application and go to Attendance, which is where attendance reports are generated. Here, we can choose a specific group we want to analyze, so we select the Employees Face database and review the activity of this group during the working days in Israel from Sunday through Thursday. In this view, we can identify who arrived late, who left early, and who was absent on a given day. Since the official workday starts at 8 a.m., we can adjust the workday start time to 8 and set the end of the workday to 5 p.m. After clicking Search, the system shows that an employee named Hedva arrived late today, based on her face being captured by one of the office cameras. We can also switch to monthly statistics, where we clearly see how many times each employee arrived late, how many days they left early, and how many days they were absent during the month. If we click on one of the employees, we can clearly see her activity throughout the month. This includes a daily breakdown with snapshots showing exactly when she arrived at the office and when she left. If we are looking for a specific anomaly, such as employees from this group who arrived late during the month, we can enable the Advanced checkbox and select the relevant parameter. This allows us to filter only those specific events or anomalies and view precise statistics related to them. If we want to focus on a specific person, we can simply type in their name and the NVR will display only that individual's abnormal activity for the selected month. Clicking the Details button then opens the same detailed interface we reviewed earlier. The Face Check-in screen is focused specifically on people's attendance, rather than on attributes such as arriving late or leaving early. Here, we can select a specific group of people and define a specific area by choosing the relevant cameras, then review whether those individuals have attended during a selected period, such as today or over an entire month. By clicking Details, we can open a window showing the activity of a specific person. As in the Face Attendance screen we reviewed earlier, an Export button is also available here and can be used to export all this information to an Excel file. The Excel report reflects attendance status, and for individuals who were present, it shows when they were captured by the different cameras.